All right, everybody, welcome back. This week we're going to finish up part 2, module 2. We're going to go through 2.6 and 2 to 2.9. It's a fairly easy week, I think. All we're talking about is errors and how to predict them or fix them or make sure that something doesn't break your code. You will have one lab, a screenshot, and then one assignment to do this week, plus the part 2 module 2 test in Networking Academy. Yeah, so I'll try and keep this short and sweet. When you are coding and something doesn't work in your code, you will get an error, and you may have seen these in your console already, big red stuff that's telling you stuff. Half or probably more of coding is figuring out what these errors mean, where they are, and how to correct them so that your program runs smoothly. Once you can figure out what it's telling you and how to fix your code, you run into a lot less problems. There are several types of errors that you may see, and we're going to cover some of the most common ones right now. So let's say I want to write a simple program that does some division, right? And let's see if I run this. It says enter a number. So when you write something, you will think it's great. And then you give it to someone to use, and they will figure out how to break it. It's how it happens, especially if you do something you're going to spend. If you decide you like coding, you want to make a program that does a thing. And when you finish this course, you're going to know how to create an executable file that you can hand to other people. Say, hey, I wrote a program that does some cool stuff. Here you go. Once you start handing it out to people, they're going to use it in ways you hadn't thought of. And they're going to cause errors, going to crash, and they're like, oh, it doesn't work. So you have to make sure that you can kind of predict some of the most common mistakes. You can't predict everything. And that's why nothing ever seems to work. You know, if you're a gamer, put out a brand new game, then the week after they put it out, they find all these bugs, and you got to go back in and fix them. Nothing's perfect. We're all human. So we got to try and figure out how this works. So if you wrote this simple program, says, hey, this will divide 10 by whatever number you put in there. And I'm like, oh, that's cool. Let me put 2. And you're like, no, I needed you to put 2 like the number. But they just thought that. So in this case, we get a value error. And a value error simply means, it's hard to interpret this sometimes. It says invalid literal for int with a base 10 to. That's some fancy schmancy talk for you put in a string and not a number. So you get this value error. Well, how do we make sure that doesn't happen? And we're going to do that with a try and except. And some languages call them try catch, but this is try and except. Or yeah, except, like an exception. Not accept like you're getting something, but exception. So we're going to try to do this. And then we're going to that's going to be called a try block. And then if there is an exception, we want to do something else. Print, please enter a digit, not a string. They don't know what that means, but basically you and I do, okay? So if I run this again, and somebody puts in 2, well, it says, instead of getting that big blocky text, it's just, so your user won't see that text. It just won't work, and they don't know. You and I as developers will see that red text and know that, okay, we need to fix something with our code. Obviously, this should be wrapped in a while loop that continues to go so they can enter another number and all that other good stuff, but we're just concentrating on the try and accept right here. So this is how we do error checking, try and accept. So right here we have made an exception in the event somebody types in a string instead of a number. But how else could they mess this up? See if they enter 0, you cannot divide by 0. So we don't see that red text right now. And it says, please enter a digit, not a string. Well, we did enter a digit. So that doesn't work correctly. If you remember, I just said the value error. The value error is if you do a string. So if I run this again, put in 0, we get that red text again. So we're just catching the value error. We are not catching this 0 division error. In order to catch that, we also have to do 0 division error. We have to specify the error. By 0. And then if I run this again and enter 0, it hits on that 0 division error and says, hey, you can't divide by 0. Again, wrapped in a while loop, and we get them enter another number. So if they enter a string or a 0, it will fix that issue. Those are the two most common, and you're going to see them harp on the 0 division error in the text. And that is the difference also between, so you can just do the except like I did the first time without the value error in there, and it will catch whatever exception it throws. It will do something. It is best to specify as many of the actual errors as you can, and that way you get a distinctive course of action. In this case, we're just printing different things. But if you need the program to go down run one route if there's a value error, and do another thing if there's a 0 division error, this is how you do that. And of course, if you just want to catch all the exceptions, just do the except block. It's not very elegant, but it works. The only other real error that we need to talk about is the index error. So let's say we have a list 1, 2, 3, 4, 5, and we want to print the index 6. Now, obviously it's not there. You got 0, 1, 2, 3, and 4. We want to print 6. What's going to happen? It's going to say you're going to get this index error. It says list index is out of range, which basically means that index doesn't exist. So we're going to do a try. And an except. And then just a print statement. That index does not exist. So if I run this, it just says the list of index does not exist. If I go back here and print 4, it'll print out the index. There's no error. But if someone tries to print, oh, that's -1, okay. So, but anyway, if you try to print the 5 or the 6, it will trigger the exception, and it is always triggering that index error. So it's best to specify the index error and go with that, because this is what you want to happen if they do something out of the range. And that is try catch, try except. So we got one more thing. The only other, if I want to say A equals, this is sentence. And print A, right? This should work super easy. It prints this as a sentence. But if I tell it to print B, you get a name error because the variable is not defined. Now that's something you ought to know, because you will probably see that error quite often if you spend any time coding, you forget to define a variable. So you need to know what that name error does for you. This isn't something that generally you're going to do a try and except block for. This is you're going to fix that you're going to declare the variable in your code, and then the program will work fine. You just mistyped. These errors, quite honestly, are nobody likes to see errors in their code, but once you learn how to interpret them, you can figure out what's wrong with your code, go back through, fix it, and then your program works properly. So that is try catch, that is error catching, and that is the lesson. You are going to do a math errors assignment this week. You want to accept 2 inputs from the user, ask if they want to multiply, divide, add, or subtract. I feel like we've done this before early on. Perform the calculation, return the result, and you want to make sure that you use a try and accept, just like I did in the lesson. Make sure I can't enter text like TWO for 2, and make sure I can't divide by 0, and that's it. Super simple. So I hope you all understand this, and if you have any questions, let me know. Thanks.